Hey guys, welcome back. In this video we're going to fix the stem by adding some vertex color, and the plan is what we're going to do is pack the vertex color information as a series of masks that we can then use to drive shader effects in Unreal. We're going to keep it really simple. It's just going to be a simple two color blend, but also what we're going to do is we're going to use the vertex color to drive a wind effect as well, that the level designer can sort of dial in how much wind and where they want the wind to start from on this. So we're going to be using the vertex color channel as almost like a data storage unit rather than it simply just being color. So let's get started. I'm here where I was in my sort of testing scene in Unreal. And you can see we're starting to get there. There's still obviously a few things that need to be done, but primarily now we're sort of working within Unreal and just bouncing the information backwards and forwards and getting those attributes that we need. So what I'm going to do from Unreal, if you've got the Houdini Engine plugin installed, I'm just going to click on File, Open Scene in Houdini, and that will launch a new Houdini session. And it'll be linked up to your Unreal project as well. So that's really useful if you want to just bounce data backwards and forwards without having to re-import and rebuild and things like that. You're almost creating like a live link between the two systems. So there we go. If I press L over my network view, you see it's brought in the ivy from the scene, and we can jump in and continue to work on our digital asset here. And before we can work on it, I just need to right click and allow editing of contents. Now once we save this asset, the save will be transferred straight across into Unreal as well. So here we are, we're exactly where we left off. I'm just going to put myself back to where you guys would be, so just bear with me. So here's where we left off. We've got our basic implementation, and all I've done is I've just added a simple transform node just after this UV project where we can set the scale of the leaves, because I was thinking the leaves looked a little bit big. So that's another useful parameter that we could pass on to the end user if they wanted to tweak the size of the overall leaves. And I found a value of 0.7 works for me, so I'm going to leave it at that. Okay, so let's make a start on this stem here. So if you remember, once we come into this for each loop, what we're doing is we're splitting off into two systems. This is the leaves, where we assign UV coordinates and all that good stuff. And this here is the stem. All right, so let me get rid of that template flag. So the plan is, what we want to happen is we want a gradient from bottom to top. And we're going to use this gradient in a couple of ways. One way we're going to use it will be for the mapping of a blend between two colours. Okay, so we can have like a nice deep woody brown fading onto like a light green at the tip there, just to give us a bit of visual interest. In addition to that, we're going to use another channel of the vertex colour to drive a simple wind node in the Unreal material editor. So we're going to have another ramp that goes from bottom to top, but this will dictate how much the wind affects the stem and the leaves. Okay, so obviously we might not want the very base of the stem to respond to wind, but perhaps we want these areas at the tip to respond quite a lot to wind. And this is again another parameter we can promote, that the end user can really dial in to get the look that they're going for, and using the vertex color information to drive that wind effect. So let's just take a look at how we are going to achieve that. So I'm over here where I'm looking at my stem, and how can we create this gradient in the relevant channels. Okay, so what we can do is, after we've got this stem value here, okay, and we can make use of an attribute that the L system has given us. So if we jump across to the geometry spreadsheet, okay, and on point attributes here, you can see all the attributes that make up our L system. And we've got this thing called age here that the L system has given us, which is, as it would sound, an age attribute of how old the point is in the L system. So 0 is the most recent, most newest point that's been created, and then here 2.9 is the oldest point. So there we go, we've got kind of our gradient there from the bottom, which will be the oldest, to the newest, most recent, which will be right at the very, very tip. So we can remap this attribute into a 0 to 1 range and then pack that into a color channel on the vertex color data channel. So let's do that. So the way we're going to do it, we're going to make use of a little bit of code and a little bit of attributes, attribute wrangling, but it's nothing scary. All we need to do is grab this maximum value and then divide the individual point number by that maximum value to get a range between 0 and 1. So we can do that with an attribute promote. Okay, and I'm just going to plug that in to our stem. And the original attribute that we're working with is called LAge. All right, its original class is point. We want to promote it to be a detail attribute. Okay, and if we take a look in our detail attributes here, you can see it's promoted the LAge attribute onto the detail level. Okay, now the promotion method is currently set to average. We don't want that. We want the maximum value, so we can change that over to maximum. And there you go, we get the maximum age value. Now we can use this in a wrangle node to create that clamped 0 to 1 range. Okay. One thing we need to be aware of, by default the attribute promote will delete the original LAge. We don't want it to do that, we want to keep hold of it. So just double check in your point spreadsheet that you've got that LAge attribute. And with that, let's do a little bit of maths on it with an attribute wrangle. Plug that in there. And here all we want to do is just grab it, so we can create a new float attribute called let's see, max age, and we'll grab it from that detail channel there. Okay, so what we've done there is we've just grabbed this value and stored it in a value called max age. Okay, and then we want to take our existing age on the point and divide it by that max age to get that range from 0 to 1. Okay, so we can create a new float attribute called we'll call this one ramp. Sorry, let me get that right. Call ramp equals at LAge divided by max age. Okay, and in fact, if I do it this way, we'll be able to see it in the spreadsheet view. So so we've just defined a new attribute of type float called color ramp, and then we've just taken the existing age value and divided it by the max age. So now you can see in the point spreadsheet we've got a ramp attribute called call ramp that goes from 0 to 1. So we've remapped that range value from 0 to 1. Okay. So now that we've got this, we can start packing this into, we can start using it in places. Okay, so the first thing we want to do is generate a color ramp that blends between top and bottom for the color gradient. Okay, and also we need to create that wind blend as well. So we need to start packing this into the vertex color channels, because if we look at the vertex in the spreadsheet here, the only data we've got on the vertices at the moment are the UV channels. Okay, we need to populate this with those color mask information, and we'll do that in the next video because this one's been dragging on a little bit. So thanks for watching, and I'll see you next time.